Welcome to lesson number 1, Types of Matter. Our objectives for this lesson: differentiate between elements, compounds, and mixtures, as well as determine if a mixture is homogeneous or heterogeneous. Recall that matter is anything that has mass and takes up space, which we call volume. And we can classify matter. So first, what isn't matter? Matter are things that do not have mass and take up space. Things like light, heat, and sound. Once we classify something as being matter, we can further subclassify that. So if the matter can be physically separated, we classify that as a mixture. And if it's a mixture, is it uniform in composition? Meaning, is it evenly distributed? If the answer is yes, we say it is homogeneous. It's a homogeneous mixture. Homo means same. And a most common example in this course would be a solution, when you dissolve something in, let's say, water. If it's not uniform, it's not evenly distributed, we say it's heterogeneous. If the matter cannot be physically separated, it can be chemically separated, we say it's a pure substance. And we can classify pure substances as either being elements or compounds. So, can we chemically decompose it? Can we break it apart chemically? If the answer is yes, it's a compound. If the answer is no, it's an element. So let's look at pure substances first in more detail. As mentioned, pure substances are elements and compounds. Each substance, either element or compound, has exactly the same composition throughout the entire sample. Elements are substances that cannot be broken down. These are on the periodic table. They are the simplest form of matter that we have. They're basically the building blocks of all of our other substances. So when you have an element like nitrogen or hydrogen or lead, let's look at, say, nitrogen first. If I have a sample of nitrogen and it's an element, that means the whole sample is made up of all the same types of atoms, which are nitrogen atoms. There are no other atoms present in that sample. Element symbols: we have one capital letter like N or H, and if there's more than two letters, the second letter is always going to be lowercase. And again, some examples are the hydrogen, nitrogen, and lead. We have different types of elements. We have monoatomic. Mono means one. Atomic means atom, so one atom elements, meaning they're composed of a single atom that's not bonded to its neighbor. So example would be sodium metal on the periodic table. So if I took a sample of sodium metal and I wanted to zoom in and look at it, if I could do that, I would see in this sample all of the same type of atoms, because it's an element, and see how they're not connected. They're not chemically bonded together. So they're single atoms, monoatomic elements. We also have diatomic elements. They're still elements, but di means two, so they have two atoms that are chemically bonded together. An example of that would be hydrogen. So if we can look in at that sample, it would look something like this, where we have all the same types of atoms, they're all hydrogen, and notice that there's two bonded together, making it diatomic. Diatom, meaning two atoms connected. And you have to memorize these elements. There are 7 elements that, when they are not in a compound, they're not hooking up with another type of element, they will be diatomic. And a way to remember this is Brinkelhoff, and it spells it out. So Brinkel is bromine, iodine, nitrogen, and chlorine, and then Hoff, hydrogen, oxygen, and fluorine. So what I want you to do is, in your periodic table right now, what you can do is you can actually either highlight, color in, or box in the 7 diatomics. And it actually starts at the number 7, and it forms a 7 up to hydrogen. So we can also say 7 up is another way to remember that, or that Brinkelhoff. So if you highlight this, or again box it in on your periodic table, you'll get accustomed to seeing these and remember that they are the diatomic elements. Compounds, the word compound means two or more, are made up of 2 or more different atoms chemically combined. So we had our diatomic elements where there are 2 of the same types of atoms. What makes a compound different is that they're different atoms put together. They have a fixed composition. What does that mean? It means that it doesn't change. So for example, water is H2O. It's never going to be anything else. It's not going to be HO, H3O. Those are different types of compounds. And so it's a fixed ratio or fixed composition. And we can take compounds and we can chemically separate them. We can decompose them back into their pieces. And their pieces are going to be their elements. So for example, carbon dioxide, which we're breathing out right now, can be, here's my carbon dioxide model, it can be decomposed or chemically broken apart back into elements like carbon and our diatomic oxygen. Let's check your understanding. Can you differentiate between elements, compounds, and... Now let's go back to our classification of matter. We already covered the pure substances, the elements, and the compounds. So now we're going to focus on mixtures, things that can be physically separated. So a mixture, unlike a compound, is two or more different substances that are physically combined, meaning they're not chemically connected. They're just in the same space at the same time. Like your groups in class are a mixture of people. You're not chemically connected. You're just in the same physical space at the same time. Mixtures have a varying composition, meaning there's no set amount. Like when we had our compounds like H2O, there was a set amount. In a mixture, you could have any amount. For example, in your groups, I could have 3 boys and 1 girl, or 2 boys and 2 girls. There's no set amount. And each substance in a mixture keeps its own properties, unlike compounds. Just like you and your groups have your own individual personalities. They don't change. There are 2 types of mixtures. We have the homogeneous mixture. Homo means same. These are substances that are uniformly or evenly mixed in the sample. So all solutions, anything you dissolve in water, for example, are homogeneous mixtures. So example, if I take salt and put it in water, I make salt water. And we would write that NaCl, sodium chloride, is salt. And I'd put this parentheses with AQ. And AQ stands for aqueous, which means it's dissolved in water. So whenever you see that AQ, it means that you have a solution, and we then assume it's homogeneous. It's evenly mixed. There's no separation of the particles. They're all evenly or uniformly spread out. A heterogeneous mixture is when the substances are not uniformly or evenly mixed or spread out. So a great example would be oil and water. Okay, it's not a compound. We have 2 different substances that are in the same space at the same time, but they're not chemically mixed, chemically combined. And you can see that it's not uniformly or evenly spread out. We have the oil up top and the water on the bottom. So this is a heterogeneous mixture. So let's see some examples here. Let's classify the following 2 things as either an element, compound, or a mixture. So NaCl, S. S stands for solid. So I have sodium chloride. Well, I have 2 capital letters, meaning 2 different elements. Because they're next to each other in the formula, they are chemically combined. So 2 different elements chemically combined, that would be a compound. Now I have NaCl and I have this AQ, aqueous. Again, recall that aqueous stands for dissolved in water. So we now have a solution, and all solutions are a mixture, and specifically a homogeneous mixture. And so looking here, you can kind of see that. So here is my solid NaCl. It's a compound. I'm taking this and putting it into water, and the end result is I have water particles, and then I have my Na, my sodium, and my Cl all floating around, but they are not connected, not chemically bonded, and that's why it's a mixture. They're in the same place at the same time, and they're just physically in that same space, and we can physically then remove them to get back to our original substances, which are water and our solid sodium chloride. A couple more important things. If a single symbol is present with 1 capital letter, that's an element. If there are 2 more symbols combined with 2 or more capital letters, as we just saw in that last example, that's a compound. All elements in compounds are always going to be uniformly spread out, so they're all homogeneous. And there's no chemical formula given or found it doesn't have a fixed ratio, and therefore it has to be a mixture, either heterogeneous or homogeneous. So for example, dirt would be a good example of there's no chemical formula given, and therefore it's not a fixed ratio, and that would be a mixture. So let's check your understanding. Can you determine if a mixture is homogeneous or heterogeneous? At this point, you should be able to differentiate between elements, compounds, and mixtures, and determine if a mixture is homogeneous or heterogeneous.